Hello guys, so welcome back to the naming of organic compounds, and this time we're going to look at how to give names for alkyl halides. So just a basic definition of alkyl halides is are organic molecules in which your alkyl group contains one or more halogen atoms. Okay, so there are two ways of naming alkyl halides. The first way is what we call as substitutive nomenclature. So in this case, the halogens are treated as substituents or they are written as prefixes. So if you see, for example, these atoms in the molecule fluorine, bromine, chlorine, and iodine, then we use these following prefixes. Now, the similar rules apply for alkyl substituents. So what do I mean with this? In this case, the carbon chain is numbered in the direction that gives to the substituted carbon the lowest or the lower number. Now, let's take a look at this example. So you have here this molecule, and it's apparent that you have two halogen atoms, bromine and chlorine, and the longest continuous carbon chain has 4 carbons, so the parent is butane. Now, at carbon 1, you have a chloro substituent, and at carbon 2, you have a bromo substituent. So when you write the final name for this one, do not forget that the substituents are written in alphabetical order. So in this case, the final name becomes 2-bromo 1-chloro-butane. Now let's look at this example. So the first thing we have to do here is actually to find the longest continuous carbon chain, and that will be the parent. So in this example, we have 6 carbon atoms, and that is your hexane. Now, if you look at, for example, the substituents, you have a chloro substituent here, you have a chloro substituent here, and you have a methyl substituent here. Now, always number this chain in such a manner that it will give you the lowest possible set of locants. In this case, it will be 1, 2, 3, 4, 5, and 6. So doing that, okay, we recognize that at carbon 1 and carbon 4, you have the same substituents, so we use the prefix di. So it becomes 1,4-dichloro. Now at carbon 3, you have a methyl group, so you have 3-methyl at carbon 3. So the final name will be 1,4-dichloro 3-methyl hexane. Now, the other way of naming alkyl halides, okay, is what we call as the functional class nomenclature. So for this type of nomenclature, the alkyl group and the halide are designated or written as separate words. So if you see the halides or the halogens, okay, we actually spell out the name of the halogen, and the halogen's name ends in IDE. So for example, fluoride, this should be bromide, chloride, and iodide. Now the alkyl group is the longest continuous carbon chain. So let's take a look at this example. So in this case, the alkyl group has 4 carbons, so that is your butyl, and the halogen is the halide is the chloride, so this is chloride. So the final name is given as butyl chloride. Now, in functional class nomenclature, the alkyl group is named on the basis of its longest continuous chain, beginning at the carbon to which the halogen is attached. So be careful this one, okay? So number the chain at which the halogen is attached. This is only true for functional class nomenclature. So in this case, you have, since the bromide is actually attached to this carbon, then this carbon becomes carbon number 1. Okay, so in this case, this is 1, 2, 3, 4. This group is butyl or butyl, and this group here, the red group here, is actually ethyl. So then the name for this molecule is now 1-ethyl-butyl bromide. Again, we write the alkyl group separately from the halogen or the halide. Okay, so how do we give names for alcohols? So just to give you a definition of alcohols, alcohols is where you have, for example, an R group, okay, bonded to an hydroxyl group, something like this one. So for for this to be classified an alcohol, this group, the R group, should be sp3. Okay, so this OH is what we call as the hydroxyl group. All right, so how do we give names for alcohols? So for IUPAC substitutive nomenclature, the names of alcohols can have as many as 4 features. That is, the name for alcohols can have, or it should show the locants, prefixes, the parent compound, and the suffixes. So we'll go to this one, okay, using this example. So when I say locants, this is just the carbon atoms to where your substituents or your branch points are located. So these are the numbers in the final name. Now prefixes, these are basically your substituents. So if you have similar substituents, then you use the prefixes di, for the same substituents, tri, for 3 similar substituents, etc. Okay, so the parent compound, this is the longest continuous carbon chain bearing the hydroxyl group or the OH group, and suffixes. So in this case, okay, the final name for alcohols, it must end up in OL. So in this case, it's named as hexanol. Now, how do we give names for these? Are actually the rules. We'll try to look at this one by one. Okay, so we select the longest continuous carbon chain to which the hydroxyl group is directly attached. So in this case, make sure that when you choose the parent chain, it should actually contain the OH group or the hydroxyl group. Now, the second group is the alkane name or the ending is changed, okay? So we drop the E and add the suffix OL, so it becomes an alcohol. The third rule is that the number, the longest continuous carbon chain, so that it will give the carbon atom bearing the OH group the lower number. In other words, when you number the parent chain, you always start at the end nearest the OH or the hydroxyl group. And the last group will be indicate the position of the hydroxyl group using number as a locant. So this means that when you write the final name, do not forget to write the number where the OH is attached to the parent chain. So let's try to apply these rules in the following examples. So, okay, this is quite an easy molecule, just 3 carbon molecule. So this is the alkane name for this one is propane. Again, we drop the E and change that one to OL, so this becomes propanol. Okay, now where is the hydroxyl group attached? It's at carbon 2. So you have to indicate, okay, the position or where your OH group is attached to the parent chain. So in this case, it is at carbon number 2. Now the other name for this one is your isopropyl alcohol. Now, okay, so we have here a bigger molecule, but it's easy to name. So in this case, we have to find the longest continuous carbon chain bearing the hydroxyl group, and this is this one. Okay, so 1, 2, 3, 4, and 5. So 5 alkane is pentane, but since this is an alcohol, so we drop the E and it becomes pentanol. Okay, or 1 pentanol, just to indicate that the hydroxyl group is bonded or is attached to carbon 1 of the parent chain. Now, do not forget at the carbon 4, you have here a substituent. This is a methyl substituent. Okay, so the final name will be 4-methyl-1-pentanol. Now, in some older literatures, okay, it's also accepted that this one is named as 4-methyl-pentan-1-ol. So both of these ways of naming are correct, except for this one. So try to guess why 2-methyl-5-pentanol is not right. Okay, so let's take a look at this third example here. So you have here a presence of 3 hydroxyl groups. So what did we say again? What do we say again if we have the presence of similar functional groups. So we use the prefixes, right? So in this case, there are three the same hydroxyl groups. So this is triol. Now, find the longest continuous carbon chain, and this is it. Okay, so 1, 2, 3, 4. Then number this one in such a way it will give you the lowest possible set of locants. So it's done for you in this example. So 1, 2, 3, 1, 2, and 3. So the final name for this one is 1, 2, 3 butane triol. Try to consider this molecule. So first we have to identify the parent chain, okay? And in doing so, we have to find the longest continuous parent, okay, or the longest continuous carbon chain, I should say. So in this case, we can have a choice, okay, or choices. In this case, we can have this one, which has 8 carbons in it, or we can have this, which has 7 carbons in this, for this way. Now, the thing is, we have to understand that when you choose the longest continuous carbon chain for alcohols, this longest continuous carbon chain should actually contain the hydroxyl group. So in this case, for this example, okay, even though it has 8 carbons, the problem with this one is that this, if you choose this, the hydroxyl group is not included in the main chain. In contrast, okay, even if you have 7 carbons here, okay, this chain, okay, includes the hydroxyl group. All right, so this way or this manner of choosing the parent chain is actually, okay, the right way and not this one. I hope this one is clear. Okay, so we choose this one now, 7 carbons as the parent, that is heptane. Again, we will change this one by dropping the E and appending OL, so it becomes heptanol. Well, we'll do that one later. Okay, now, how do we actually number the parent chain? So again, we could number it in this manner, okay, or in this way, okay? So if you number it in this manner, you have locants or sets of locants to be 2, 3 versus 5, 6, okay? So in this case, okay, this one we will follow this because 2, 3 will give you a lower numbering than 5, 6. Okay, so we use 2, 3. Now, when you write the final name, okay, remember, okay, we should write or identify the parent first. Okay, that is 2-heptanol. Again, why is it 2-heptanol? Again, we agreed earlier that the longest continuous carbon chain has 7 carbons. So if you convert that one into an alcohol, that becomes heptanol. And do not forget to write, okay, the locant or where your alcohol or the hydroxyl group is bonded. So in this case, because this is at carbon number 2. So the parent name becomes 2-heptanol. Okay, how about the suffix? The suffix is just the substituents, and this is a propyl group. And where is it located? It is at carbon number 3. So the complete name becomes 3-propyl 2-heptanol. Now, how do we give names for cycloalkanes? Okay, so what are cycloalkanes? I think we've discussed this one previously. So cycloalkanes, these are basically alkanes, okay, but they are in cyclic forms, okay? So for example, you can have here this one. This is it looks like a triangle, but this in organic chemistry, this is known as your cyclopropane. So you can also have another type of cyclic alkane, okay, having this structure. Okay, this is known as cyclobutane. So these are called monocyclic compounds. Now, how do we give names for this? So cycloalkanes in only one ring, again, these are known as monocyclic compounds. Okay, so it's the naming for cycloalkanes is very simple. We just add or attach the prefix cyclo and the name of the alkane. So example, cyclo Propane. Why propane? Obviously, this has 3 carbon atoms, so it's propane, cyclopropane. This one is, okay, 1, 2, 3, 4, 5. This is pentane. Again, the name of this monocyclic cycloalkane is cyclopentane. Now, how about for substituted cycloalkanes? So in this, let's take a look at this example. There's just one substituent, so it's quite easy to name this. So in this case, we just name this one as isopropyl cyclopropane. Now, take a look at this example. Okay, again, okay, you have here a methyl group, a CH3 group here. So this one is named as methyl cyclopropane. Again, this entire thing here is your cyclopropane, and this one is your methyl group. Now, how about for this one? Okay, again, you should recognize that this one is your third butyl group. Okay, so this one is named as third butyl cyclopentane. So the naming for monocyclic compounds is just easy. Now, let's take a look at four cycloalkanes bearing 2 or more substituents. So in this case, the rule of the thumb here is just to give names in such a way that the substituents should have the lowest possible set of locants. So in this case, okay, we should recognize that this substituent is an ethyl group and this substituent is a methyl group. So in this case, the lowest possible set of locants is made by counting the cycloalkane ring in this manner: 1, 2, 3, 4, and 5. So doing so, what do we have here? It's 1 ethyl, 3 methyl cyclopentane. Now, when you write the final name, okay, make sure you have to arrange the substituents in alphabetical order. You should be able to know, okay, what is wrong with this naming. This one is named as 1 ethyl 4 methyl cyclopentane. And you should also be able to know or to reason out what is wrong when we name this molecule as 3 ethyl 1 methyl cyclopentane. Let's take a look at the second example. This one is that when we have 3 substituents in the in the cycloalkane ring. Again, the basis here is to provide the lowest possible set of locants for the substituents. Doing this, there's only one way to number the ring, and that is by numbering this as 1, 2, 3, 4. So in this case, it becomes 4 bromo, 1 ethyl, 1 methyl cyclohexane. Again, the substituents are written in alphabetical order. Now, what is wrong with this? So in this case, the namings or the numbering of the chain started from 1, 2, 3, and 4. And this one gave a 1, 3, 4 combination. And obviously that is a higher combination of locants as compared to 4, 2, and 1. So hopefully there are no questions for this. This is actually a nice example because you have here, a functional group which is a hydroxyl functional group and the presence of your alkyl groups. So in this case, we actually numbered this carbon atom bearing the OH group as carbon number 1 always. Okay, if you have a hydroxyl group, why? Because your hydroxyl group is of higher preference or higher priority than your alkyl groups. Actually, we have this functional group prioritization in giving names for organic compounds, and this will be the topic or the last topic of this lecture. So in this case, carbon 1 is this, it's the carbon bearing the OH group. So the name becomes, the parent becomes 4-cyclohexanol. And numbering is done in this manner: 1, 2, 3, 4, 5, and 6. Why? Because doing so will give us the lowest possible set of locants. So the name for this one is 4-ethyl 3-methyl cyclohexanol. What is wrong with this? 1-ethyl 2-methyl sun for all. Okay, again, this violates, okay, the prioritization of functional groups. OH, or the hydroxyl group, is of higher priority than your alkyl groups. So the last topic about naming cycloalkanes is for cycloalkanes bearing, for example, let's say an alkyl group which has more number of carbon atoms. So in this case, let's try to consider this example. So you have here your cyclobutyl attached to a alkyl chain which is 5 carbon atoms. So in this case, the naming is cycloalkyl alkanes. So in this case, the cycloalkane group becomes a alkyl group. So the naming becomes 1-cyclobutyl pentane. Now, when is the cycloalkyl alkanes naming followed? So aside from this, okay, this type of naming is also followed when we have more than one ring system attached to a single chain. So example, so you have here 1, 2, 3, that is your chain, and you have here, okay, you should recognize that these are cyclohexane. So this molecule is named using this convention, cycloalkyl alkanes. So again, the cycloalkane groups becomes your alkyl group. So the naming becomes 1,3-dicyclohexyl propane. So obviously it has 3 carbons. So this one is your propane. So that's the last topic about naming of alkane.